Hi, I'm an old guy and I do maths. What is the general solution for sine x minus cosec x equals 0? This is a tasty problem. And there are at least a couple of ways of doing this. The way that I've chosen to do it is to use a fairly simple trig identity, I suppose you'd call it. And I'll point to that now. It's down the bottom of the page. A cosecant is equal to 1 over the sine. So the first thing I'm going to do is I'm going to rewrite this in that form. So sine x minus 1 over sine x is equal to 0. How does that help? Well, at least we're dealing in the same ballpark. We're dealing with sines now. The next thing to do is to multiply through by the sine of x, which will rid us of this pesky fraction. So if we do that, so sine x, what we get is we get sine squared x, which we will deal with in due course, minus sine of x over sine of x, and that equals 0. Now, this is equal to negative 1, so we have sine squared x minus 1 equals 0. This is something that we can deal with. Now, we have to deal with this, but that's pretty simple. What we do is we take the square root of this, but before we do that, let's just do a little bit of rearranging so we get to that point. Sine squared x equals 1. Okay, so what are we looking at then? Well, we find the square root of this, and that is sine of x is equal to plus or minus 1. And if we go looking for where the sine of x is equal to 1, let's just draw a little sine graph here. The sine of x is equal to 1 at that point, and at that point on a sine graph. By the way, negative 1, positive 1 and negative 1. Right, so the question is, what is that point? Well, this is 2 pi, this is pi, this therefore by symmetry is pi on 2, and this is 3 pi on 2. And so we are in business. We've got our starting points. So they are as follows: pi on 2 and 3 pi on 2. Now, the question is, what do we add or subtract to these to get a general solution? Back to the unit circle. Let's just consider these points. They are here and here. If we start here at pi on 2, we have to go 2 pi to get back to that. And if we start here at 3 pi on 2, we have to go around 2 pi to get back to that. Now, it would indeed be possible to write this, I think, as a single expression for a general solution, which would be to start here and add pi and add pi and add pi, or to start here and subtract pi, subtract pi, subtract pi, and we would always wind up at either plus or minus 1. So if you feel like neatening up my work, please feel free to do so. I'm going to write this as this, 2 pi n plus or minus 2 pi n, which means that we start here, we go round 2 pi, we go round 2 pi as many times as we like, and we end up here, or we go in the other direction. And the same for this, 2 pi n. But as I say, this could be probably tidied up to pi on 2 plus or minus pi n, because these two points are opposite on the unit circle. However, I suspect, and I haven't gone to the bother of checking this, but I suspect that if you asked your calculator to solve this, you might get a solution that looks like this. Anyhow, I think either of those would be a valid option. I've gone for this one. Thank you very much for watching. I hope you found this useful. And if you did, please like and subscribe. And I'll see you next time. Bye.